and Julia Sondu, showing you where development is happening. Please come and join us. Here is the biography of a wonderful Ghanaian scientist who invented the high-voltage water purification method at NASA's Glenn Research Center in Cleveland. The high-voltage water purification method was invented and developed by Dr. Isaiah M. Blankson and Dr. Grigory Adamovsky of Glenn, and Dr. John E. Foster, of the University of Michigan. Unlike most conventional purification processes, which are based on filtration and direct chemical injection, Glenn Research Center's approach uses high-voltage, nanosecond pulsed, non-equilibrium plasma to treat water. The pulsed electrical discharge destroys microorganisms in liquid, essentially sterilizing the water, without the use of toxic chemicals or filters. Originally developed as a means to recycle water in space, this technology has applications in industrial water treatment, water recycling, and water purification for military bases, disaster sites, and regions without easy access to clean water. Aerospace scientist Isaiah Blankson was born on September 28, 1944 in Cape Coast, Ghana. He received his BS degree in 1969, MS degree in 1970, and PhD degree in 1973, each in aeronautics and astronautics, from Massachusetts Institute of Technology. Isaiah M. Blankson, 69, MS 70, PhD 73, completed his secondary school studies at the Mfansipim School in Ghana. Nobel Prize winner and former UN Secretary-General Kofi Annan MBA, 72, is a fellow alum of Blankson's, both from Mfansipim and MIT. He came to the United States from Ghana to study at MIT under the African Scholarship Program of American Universities, an international cultural and educational exchange division of the U.S. Information Agency until 1999. Blankson earned his bachelor's, master's and PhD in aeronautics and astronautics, all from MIT. He went on to a lifelong in 1982. Blankson joined General Electric Corporate Research Center, GRC, in Schenectady, New York, where he conducted research on hypervelocity plasma armature projectile launchers and gas dynamic circuit breakers. He went on to join NASA as Program Director of the Generic Hypersonics Program in 1988, and was named Deputy Director of Hypersonics Research Division at NASA headquarters in Washington, D.C., in 1991. He was promoted to Senior Technologist in the Hypersonics Division at NASA Glenn Research Center in Cleveland, Ohio in 1997. Blankson's pioneering work advanced the state-of-the-art air-breathing hypersonic wave riders and aircraft engine concepts. Blankson conducted research on non-equilibrium weakly ionized plasmas and magnetohydrodynamics, MHD, plasma discharges in dielectric liquids, and magnetic suspension systems. In 1998, Blankson, an Associate Fellow of the American Institute of Aeronautics and Astronautics, served as the U.S. National Delegate to the NATO Research and Technology Organization's Working Group on Hypersonic Vehicle Technology. During his career, he has worked to prepare the next generation of scientists and engineers, especially underrepresented minorities, by aiding the building of research programs. He led the formation of the NASA-sponsored Center for Aero-Propulsion at Hampton University, and the NASA Center of Excellence at North Carolina A&T State University, serving as technical monitor and advisor. At NASA, his contributions to the development of concepts for high-speed air-breathing propulsion resulted in many awards and patents. Included on the list of patents, the exoskeletal gas turbine engine, U.S. Patent 6,393,831 B1, 2002, and the magnetohydrodynamic power, MHD, controlled gas turbine, U.S. Patent 6,696,774 B1, 2004. In addition, he co-developed a method for weakening shockwave strength on vehicles in supersonic atmospheric flight, 2015, U.S. Patent 9,016,632 B1. Blankson has received numerous awards, including the 1969 Luis de Flores Award for Excellence in Engineering from MIT, the NASA Exceptional Service Medal in 2002, National Emerald Honors Scientist of the Year Award in 2006, 2 Presidential Rank Awards, the 2012 Distinguished Senior Professional Award, and the 2006 Meritorious Senior Professional Award. In 2018, he was awarded the NASA Exceptional Technology Achievement Medal in recognition of his development of non-equilibrium plasma technology for aerospace and terrestrial applications. Isaiah Blankson was interviewed by the History Makers on September 26, 2018. NASA Glenn, CWRU team up to commercialize groundbreaking water purification technology. Cleveland, Ohio, NASA has been sharing its space-age technology on Earth for decades, giving birth to inventions we now take for granted such as infrared ear thermometers, robotic artificial limbs and anti-icing systems for commercial aircraft. But one of the space agency's latest discoveries has the potential to provide benefits to mankind that far surpass anything NASA has patented in the past, purifying polluted water that kills millions of people every year in underdeveloped countries. And graduate students at Case Western Reserve University could play a key role in seeing that the hometown NASA innovation is properly commercialized and reaches its maximum worldwide potential. Dr. Isaiah Blankson and his team of scientists at the NASA Glenn Research Center began studying the use of electrically charged plasma, an ionized gas, to purify water. The technology itself was not new, Blankson said, but his regime was revolutionary, injecting plasma into water and bombarding it with up to 100,000 volts of electricity pulsed in short bursts of 2 to 5 nanoseconds, effectively killing every cell of bacteria in the water without raising the temperature more than a single degree. The NASA water purification treatment also removes other harmful elements such as heavy metals that elude conventional water purification systems employing filters, chemical injections or ultraviolet radiation treatments, Blankson said. Here at NASA, we were looking for someone to take this proven method and turn it into a product that produces so many thousands of gallons of pure water a day, Blankson said. The technology is ripe for implementation and marketing. Enter Case Western Reserve University and Fusion, a postgraduate program that brings together students from engineering, law and business, and assigns them to work on a different project every year. This year, they have been teamed with 4 separate water purification product designs developed by leading research labs, including NASA Glenn's invention. Each team's production concept will be developed and evaluated for potential product applications, intellectual property development and commercial viability. Water comprises a $500 billion global market, and Dr. Blankson's technology is very amenable to purification technology challenges in the class, said Theodore Theophrastus, the managing director of Fusion and a professor at Case's School of Law. Theophrastus said the Fusion students will seek applications for a portable plasma water purification unit which can be driven by solar power or gas-powered generators. The teams will attempt to identify the different types of intellectual properties needed to commercialize the product, to determine its best potential market, and to estimate the resources required to reach the next developmental milestone. Blankson said he welcomed the assistance of the Fusion teams. Even though we have the science and engineering capabilities for purifying water, we needed to address the social, the economic and especially the political challenges caused by water urgencies in the 21st century, Blankson said. Glenn and SageGuard Solutions leadership will sign a commercial license agreement for a high-voltage water purification method that relies on electricity to remove contaminants, such as bacteria, viruses, parasites, fungi, algae, pharmaceuticals, fertilizers and bio-waste, from water without chemicals or filters. By injecting plasma into water and bombarding it with up to 100,000 volts of electricity pulsed in nanosecond bursts, this method effectively kills every cell of bacteria in the water without raising the temperature more than a single degree. We are delighted to enter into this commercial licensing agreement with SageGuard Solutions. It ensures the discoveries that have come from our aeronautics research are made broadly available to entrepreneurs, said John Sankovich, Glenn's director of the Office of Technology Incubation and Innovation. NASA has already solved some of this century's most challenging technical problems, and these solutions are now being used by others in ways never envisioned. The water purification technology has applications in industrial water treatment, water recycling, and water purification for military bases, disaster sites and regions without easy access to clean water. At this time, There is a tsunami of opportunity within the water industry, and our intent is to capitalize on these opportunities to benefit society, science and business, said SageGuard Solutions CEO Ray Urquhart. The high-voltage water purification method was invented and developed by Dr. Isaiah M. Blankson and Dr. Grigory Adamovsky of Glenn, and Dr. John E. Foster, of the University of Michigan. This is the end of our program today. See you on Intervlog same time tomorrow. Thanks for watching. Please like and subscribe to my channel and press the bell icon to get new video updates. Thank you for watching Intervlog. Thank you.